implies an increase in the intensity of light incident on a light dependent resistor LDR. This causes a change in the number of conduction electrons and a change in the resistance of the LDR. Which row of the table describes these changes? Right. Okay. Right. If the intensity is increased, right, here we have the intensity, right? If the intensity is increased, then what will happen? Right. Then, right, what is the meaning of intensity? Number of photons per unit second, right? I hope you remember the photoelectric effect, right? So it is number of photons per unit time. So the number of photons will increase, right? Then they will collide with more electrons in the LDR. So what will happen? This will increase the number of conduction electrons, because there was a few photons in the beginning. Now they have increased the intensity. It will increase the number of photons per second. Then the number of photons per second will collide with the electrons in the LDR. Then it will release more conduction electrons. So it will increase the number of electrons. Right. Then what will happen if number of conduction electrons are increased? Then probably the resistance will decrease. So resistance will decrease. Right. So in this case, what we have to consider is the resistance is decreasing and the number of electrons is increasing. So the answer should be which one? C. Right. Right. This is very easy. Why? Because I hope you all know the equation for de Broglie wavelength. Lambda, this is the de Broglie wavelength, is equal to Planck's constant h over mv. Right. In this case, you have to subject just v. Right. Then it is equal to h over m lambda. Without doing any calculation, you can select the answer A. How? Right. Because we have the Planck constant over there, then the de Broglie wavelength over there, and the mass of the electron over there. So the answer is A. Right. Here, which of the following describes a change in energy of one electron volt? Right. Okay. Then let's suppose that we need to give energy for a one electron 1 electron volts energy for a 1 electron, right? Then what should we do? Right, we should have a potential difference between two plates, right? And here's the negatively charged plate, and here's the positively charged plate, right? And we'll give some potential difference between these two plates, and the potential difference will be 1 volt. Then suppose, right, we keep our electron over here. Then what will happen? It will accelerate towards the positive plate. Then if I ask you to calculate the energy gained by this electron, it is equal to W equals VQ, right? Then here W equals 1 volts times, right, the charge of electron is 1 E, or you can select it is 1 coulomb, right? Sorry, not 1 coulomb. If you write 1 electron charge in coulombs, it is 1.6 times 10 to the power minus 19 volts. So right here you can write the energy gained by the electron, it is equal to 1 electron volts. That's why when we convert our units of energy, we use right here, if I write this one in joules, then it will be equal to 1 volt times the charge is 1.6 times 10 to the power minus 19 coulombs over here. It is volt. Then this will be equal to what? 1.6 times 10 to the power minus 19 joules, right? Then right, is to equal. So here they have mentioned in the first one, a charge of 1 coulomb is accelerated across the potential difference of 1 volts. No, that is wrong. Why? They are accelerating an electron, so it has a charge of 1.6 times 10 to the power minus 19 coulombs, right? Over here it should be coulombs, right? B, a charge of 1 coulomb passes point times. No, it is 1 coulomb, not 1 coulomb. An electron is accelerated across a potential difference of 1 volt. Exactly. Right. So this is the answer. Answer C. Right. In the fifth one, the diagram shows a 1.5 cell in the circuit with 2 resistors. The cell has a negligible internal resistance. The switch is closed. What is the reading on the voltmeter? So if the switch is closed, then what will happen? The current will take the path this one, right? It will move like this, and it will take this path because it has no resistance. I mean, we assume the copper, the wires, for the wires, they don't have any resistance, right? So it will move like this, right? So we don't need to consider this 5 ohm resistor at all. So you can just neglect it because our current is taking this path. Then this 1.5 volts will be distributed across this what we call 10 ohm resistor, right? Yeah, 10 ohm resistor. So the voltmeter reading will be 1.50, right? If they have given 1.5, it's okay. That now here they have given 1.50, so the answer is D, right? Answer is D, right? Sixth one, a uniform wire is attached to a meter rule. The wire is connected in a circuit as shown, right? The distance D between the connections, the voltmeter is increased. What we are increasing? The distance D, right? The reading V on the voltmeter changes, right? Now they're asking the relationship between V and D, right? I hope you remember this equation. What equation? The resistance equals resistivity rho L over A. In this case, they have mentioned what? We have a uniform wire. So which means we don't need to worry about the resistivity and the cross-sectional area because they are uniform, right? So the resistance will be changed, right, according to the length, and they are directly proportional to each other. So what will happen to the voltage? Because we know V equals IR, right? If the R is increasing, if we increase the L, then probably according to V equals IR, right? V is also directly proportional to the R. So R is increasing, then the V also increase. So this is our equation, and here the second one. So you can write if you got these two equations, then you can write what? V is directly proportional to the length. Because why? Because if we increase length from some ratio, then the resistivity also increase from the same ratio. And if the resistance is increased from the some ratio as the L increases, voltage will be increased in the same ratio, right? Suppose I am going to increase L by factor of 2, then what will happen to resistance? Resistance also will be increased by the factor of 2. The resistance increased by the factor of 2, then voltage will be increased by the factor of 2. The same thing happen if you divide this, if you change the length into half of L, right? The ratio. So if V is direct proportional to L, you can write this one as here you can Y direct proportional X. So you can write this one as Y equals mx. So this is the type of graph, right? So if the L is 0, right? If the L is 0, V should be 0 because it is a Y equals mx type graph. So it is starting from the origin of the coordinates. So you can with A, right? Even B, here C is the answer, right? Right. In the seventh one, a microphone is attached to an oscilloscope. The microphone detects a sound. The trace displayed on the oscilloscope screen is shown. Right here we have the trace, and here they have mentioned that what one division, one horizontal division, right, represents a time of 0.015 seconds, and they're asking us what the frequency, right? The frequency is equal to what? Time taken for a one oscillation. So time taken for a one oscillation. Over there is one, right? One oscillation, and here's the time taken. Now we have to take the t. So how can we calculate t? We have to take it from the screen of oscilloscope, right? Okay, I'm going to find that time. F equals 1 over, and here What is a complete oscillation, right? Complete oscillation is here, this one, right? Up to here it is one complete oscillation, right here. And if you look at the whole screen, we have two complete oscillations. So I'm going to calculate the time taken for one complete oscillation. So we have one small square, two small square, three small square, four small square. Then we have four square, 4 times, and 1 represents 0.015 seconds, 0.015 seconds, right? So the answer is D, right? Okay, here, at a distance D from a point source of light, the light intensity is I. Which of the following expressions gives the light intensity at a distance 2D from the source, right? Okay, I hope you remember this equation. What equation? Intensity is equal to power over area, right? This is the equation. But if you try to visualize this equation, how can I visualize this equation, right? Here we have a point source, right? And it's radially emitting its all energy, right, into all directions, right? This is a 2D image, right? But you can visualize it as a 3D. Don't get confused with it, I will explain, right? Here, so then suppose this is the circle that it will create from a distance of D, right? From here to here we have a distance of D. So if you want to take the intensity over here, right, at this point, then it is equal to what? The energy passing through this point within a unit time, right? We call power for that. What is the power? Power is the energy passing through, right? Energy passing through this particular point, right, at a unit time, right? So we call this particular point what? Unit area. That's why we have A, the unit area, right? Now what we are going to do, right? What we are going to do, we are going to calculate the intensity. It is equal to I. So if I substitute my values over here, P is, they have given it is P, right? They haven't given it to you. I'm just assuming it is P, the intensity, right? Over here, P. You don't need to worry about that one, right? Over here, the area of the circle, it is 4 pi d square. You want to take the intensity at this position, it is this one. Or even if you want to take at this position, it is over this one. Even here, any point what you take, which you have taken along the circle is I equals P over 4 pi d square. Then if you are looking at the intensity, right, at the distance of 2D from the point source, right, then suppose that you are going to find the intensity at here. So now the distance is 2D, right? So I'm going to take the intensity, I'm calling it new intensity, right? It is equal to P, the same thing. Why? The energy passing through this particular point within a unit time is same, right? Will pass through even in this point at the unit time, right? You don't need to worry about that one, right? So it is P, right? We have no change in the power because it is the energy passing through this particular point at a unit time, right? Then over, now the area has changed, right? So it is 4 pi 2d square. Then if you simplify this one, you will get P over 4 pi 4d square, right? Then what I'm going to do, I'm going to divide first one. So we are going to find In, right? You have to divide, right? In over I, right? This is equation 2 and this is equation 1. I'm dividing equation 2 from 1. So it is equal to, I'm going to write In over here. It is P over 4 pi 4d square. And you have to take the reciprocal of the first one. So it is 4 pi d square over P. Then P will be cancelled out, right? That's why I told you, you don't worry about that one. 4 pi and d square also will be cancelled. Then the new I, what we call new intensity, is equal to I over 4, right? When you're doing this question, you don't do this whole work that I have done over here. What you have to do here is, what the intensity is directly proportional to the, sorry, inversely proportional to the area. So over here you can write 4 pi, they are constants. So we can write it is inversely proportional to the square of the distance, and the new one is directly proportional to the new distance, square of the new distance. So it is 2d square, which means 4d square, right? So if you divide these two, you can easily select what will happen, I over in, then it will give you 1 over 4, sorry, right? We have to divide these two, then if you divide this one, in over I, it is equal to I over 4, the same thing, right? So we are doing this question, these 3 steps are enough, right? Because we have to save our time, right? Then the answer should be B, right? Okay, in the 9th one, 2 polarizing filters X and Y are arranged between a light source and an observer as shown. Here's the light source and we have 2 polarizing filters X and Y. The intensity of light reaching the observer is maximum. Okay, the observer rotates filter X, right? The observer then rotates filter Y, so that the intensity of light is a maximum again. Which of the table shows possible angles of the rotation for the filters, right? Suppose, right, from the light source we will get unpolarized light. I hope you know this one, so I'm going to draw unpolarized light like this. Then what will happen, suppose the transmission axis of this polarizing filter is like this, then it will give us, right, polarized light like this, right? All other light will be stuck to this polarizing filter. Then if the intensity is maximum, and even in this case, right, now we have a 0 degree, we haven't rotated it still, so the transmission axis is like this, and this light will, the polarized light over here will pass through even the polarizing filter Y, right? Then, right, they are telling that it is maximum, right? It will be maximum. So if you change this one, right, suppose you are going to change it, right? You are going to change X into 90 degrees. So now the polarizing filter will be like this, and you will get the same for the Y. Now the transmission axis, so this one is here and the transmission is here. Then if you send unpolarized light like this, then it will pass through what, the X, right? Now it will pass the polarizing light like this, right? Because the transmission axis is vertical, right? So now they are vertically polarized. What will happen when they face the polarizing filter Y, right? When they face polarizing filter Y, they will get no light. Why? Because they are perpendicular. I mean, this is vertical and this is horizontal, so no light pass through it. So it is minimum. Now the intensity you observe over here is minimum, and the intensity over here you observe is maximum, right? Maximum, right? Then for minimum you should have 90 degree what, angle between them, and for this one, right, it will be 0 degrees, right? Not even in this case, if you rotate, now you have rotated X, right, into this direction. Suppose now we are rotating, now we have rotated it like this. Now I'm again rotating it another 90 degrees, which means now here you have rotated 90 and here I'm rotating it 180. So what will happen, it will come back to its original shape, back in the diagram, right? So the transmission axis is now horizontal, right? So now the angle is 180, angle is 180. So if you send unpolarized light like this, right, what will happen, right? Same thing will happen like the diagram that they have given, right? So this is unpolarized light, right? I hate drawings, right? Okay, here it will pass the polarized light, they are horizontally polarized. Then what will happen again? The light will pass through even the polarizing filter. Why? But horizontally polarized. Now we have a maximum, right? Maximum. And what about the angle, right? It is 180. So if you get like angles like 180, 0, 360, 720, you will get maximum, right? What about the angles like 90, right? 270? Difference, I'm talking about the difference between the polarizing filters, difference of the angle between the polarizing filters. So it is 90 like things, it will be minimum, right? So now we are going to check what will happen on the given data, right? Here angle rotation of x is 90 now, angle rotation of y is 180 now. So the change in the angle between the polarizing filters, to take the change, right, it is 90, right? Don't worry about the I mean, if it is positive or negative, you don't need to worry about, because we are dealing with the change. So change is 90, which will give us the minimum intensity, right? And here it is again 90, right? Again minimum. In this case, you will get the change in the angle is 180, so you will get maximum, right? So this is the answer. This one is very easy, right? Here they are telling in an atom, an electron drops from energy level E2 to energy level E1 as shown, right? A photon of wavelength lambda is emitted, right? Which of the following expressions gives the energy E2, right? Okay, so if the electron drops from energy level E2 to E1, photon will emit. And we all know the energy of the photon is equal to HF, right? Then according to energy conservation, the drop of the energy or the drop of the energy of the electron, it is E2 minus E1. That change in energy will be converted to a photon, so it is equal to HF. So instead of F, you can place what? C over lambda, right? E2 minus E1. So they are asking the energy E2, so you have to subject E2. If you subject E2, you will get what? E1 plus it's C over lambda. So the answer should be B, right? Okay.